How many of you have actually sharpened a chainsaw before? That's what our next session is going to be on, is discussing sharpening a saw chain, but also how I look at it, repairing it in many cases. You know, I think probably 70%, that's theory by Ard, of the people that I talk to that have been injured with a saw, whether it was a cut, laceration, whatever that happened, loss of control. When I go back and start to discuss with them and start to look at the situation, the chainsaw chain was dull. And what do you have to do if you have a dull saw chain? I know you need to sharpen it, but actually you have to work harder. You have to apply more pressure. You have to push and pull on the chainsaw. And in that case, it can throw us off balance. It can also increase reactive forces. And also it ends up with just a more dangerous work area to work in. So how do you know when it's sharp or dull? Two ways. The first one is you could look at the chips. A lot of people talk about that, the sawdust. If you're getting fine powder, most likely your saw is dull and you're pushing on it. If you get a good chip, that's great, kind of the distance between two cutter teeth. And then the other, if you go to the end of a log, you can pull out longer chips. I always tell people it's not the size of the chip that makes the difference, but how fast it cuts. When you start to cut a piece of wood, a log or limb, you should be cutting about 1 inch a second, maybe a little bit slower than that, but more or less you want to be moving into the wood. If you're on a piece of wood, 10 or 12 inches round, you should cut through it in about 10 to 12 seconds, maybe 15. But it should move through it. It shouldn't be sitting there for a minute, minute and a half with you pulling back and forth and smoking chain to get through that piece of material. So you want to make sure that it's doing the work for you. As we start to look though, I think a lot of the situations come about with damage. We hit something. I had a young fella several years ago, was in a class and it was on a day 3 of our program, and I had large pine log marked for him to cut through. He hadn't operated a chainsaw much before, but he was using my saw, and more or less he cut down through it. He worked down through the wood very nicely. He got to the end of it, but I kept watching him. He went through the wood and went into the ground about 4 or 5 inches. And he stopped and he said, "How did I do?" I said, "Well, you did great till you went into the dirt down here with my saw." And he said, "Oh, I didn't hit the ground." I said, "Oh, you did too. Look over here. It looks like a ditch witch trench." He said, "Oh, my goodness, I didn't mean to do that." I said, "Well, don't be sorry." I said, "I've hit asphalt and rocks and all kinds of different dirt situations, and it's just going to happen. But how we're going to be able to keep that from happening is looking. We have to make sure that we observe what we're cutting and watch it the whole time so it doesn't get into a material we don't want to cut." So, what happens though when something is damaged? We have to repair it. If you've ever had a chainsaw start to cut sideways, left or right, what do you think causes that? In reality, it's one of two things usually. I mean, you can have a worn bar, and a lot of people talk about that, but most of the time, the two parts that really make a difference are the depth gauge and the point. So as we start to look at the parts of the tooth, there's 5 parts in the design that we need to be more or less aware of to be able to either sharpen or to be able to pick another saw chain before we go to work with it. The first one out here, some people call it a drag. Technically, a lot of the material calls it a raker after an old cross-cut raker tooth on a handsaw. And then the more technical term for it is it's a depth gauge. It sets up how thick the chip is that's going to come off of this particular tooth. That dimension out of the box is usually about 25 thousandths of an inch below this part. This part is called the working corner or the point. Now going back to cutting crooked, if you think about it here, if you look from this point back here to the back, the problem is that it goes downhill. And so as we sharpen or grind this back, the point gets lower. And when that happens, it's going to raise the depth gauge. So we need to make sure that we understand that. Think through the process of it has to be adjusted. Now, as we start to look at another situation is that, let's take, for instance, we do take more off this tooth over here than we do on the left tooth. And in that case, it starts to adjust that for us, doesn't it? So let's say we have the right side cutters are a little bit shorter than the left because we've applied more pressure to it. And we have the depth gauge that's set the same. Which one would be more aggressive? Which side is it going to pull to? It's going to pull to the longer side tooth because the shorter side is going to be taking less bite with that same depth gauge setting. And then also just having the damage on the right side. And the reason why I know that is you could take and get a good sharp saw chain, brand new, and even put it into the wood. It's cutting nice and straight. Take yourself a flat file, knock about 5 or 6 points off of it, put it back in the wood. If you made those damage points on the right side, it's going to cut to the left immediately, or vice versa. So those two things, the depth gauge and the point, can keep you cutting straight and also feeding into the fiber. Any damage on that working corner or point is going to start to decrease your cutting capacity. So we want to make sure that we understand that. The next part is over here. This is called the side plate of the tooth. And this side plate really does the toughest work. It has to cross-cut the fibers in the long log or limb. And I had many times people ask me, what size file should I have for my particular saw chain? And several years ago, I got into that conversation with a chain engineer. And he said, do people ask you about what size file you should have? I said, yeah, quite often. He said, what do you tell them? I said, well, you have to really go back to the manufacturer's equipment manuals. And I do agree that that's probably one of the quickest and best places to find it. But there are several situations where they might say to use this on this tooth and this on this tooth as far as size-wise. And both chain sizes are the same, but the actual file you're going to be using might be a little bit smaller or larger diameter. And how he explained it is 1/5 or 20% of the cross-section or diameter of the file should actually be above the point, and we know what that is now, if it's in the proper position. So if I illustrate it this way, if I were to take this into 5 parts, 1/5 of it being above that point, then you would look for a visual of 90 degrees from that point to where the file rests in the gullet area. And so if we understand that, we're looking for a 90 degree. Some chains actually have a witness mark over here on the side that'll show you what that angle should be, that visual should be. And so if I were to take this out, as you can see here, see if I can erase some of this. This is what the side of the tooth would look like if it's in the proper configuration. Now, alternative to that, and that would be what we call a hook. And that's what's illustrated here. If I were to take this out now, you can see that file was down below that point. And if your chain looks like this, it's not correct. You need to make sure that it looks like the one on the left. The one on the right is going to dull quickly. It's going to grab into the material more. But the other thing is it can cause it to rock and roll and increase the chances of reactive forces taking place also. The third one I have down here, this is called a back slope. And the situation with that we usually find on smaller chainsaws like bucket saws, climbing saws, or especially on pole saws. Pole saws use an extended pitch 3/8 chain, smaller profile, or a low profile 3/25 pitch. And so what happens is if you use a bigger file diameter on that, like this one you can see it's back, you end up with the point back behind the file and you end up with a back slope on the tooth. And it takes a lot of pressure trying to get that to cut. So we want to think about understanding that side plate, making sure that looks concave, but still a visual 90 degrees vertical there. So depth gauge, the point, and the side. The fourth one is up here. This is called the top plate of the tooth. You can see I have a witness mark on that also. That lets us know when that tooth is worn out. It also helps us to align that front angle. The top angle sets up the width of the kerf. The kerf is the slot that it makes into the fiber of the wood. And so more angle you have up to a point here, it moves this tooth to this side, this tooth to this side to open the width of the kerf. You must have a width opening for the bar and chain to go down through without binding. So that's one that you really need to watch. Most full chisel chains are about 25 degrees on this front side. That full chisel is square side, square top. Semi chisel tooth, which usually has a rounded corner here, that usually goes 30 to 35 degrees. And the reason for that is it takes more movement to the side for that tooth to clear the chip on a semi-chisel tooth. So that's something on the top angle that we have to understand. And then number 5, the 5th one, is underneath the top plate. And that's called the top plate chisel angle. The chisel angle really scoops that chip out between the verticals. And that's usually set about, we say 45 degrees, like the front end of a flat chisel. But more or less, it's usually between 50 to 55 degrees that does that peeling action of the chip. So the depth gauge, the point, the side, the top, and the chisel. Now, if we could look at kind of an illustration here that kind of talks about, let's say that this is a block of wood and we're going to chisel out a opening here to more or less install, say, a hinge. I take a flat chisel, if this were one, which would have a beveled edge on it. I have a point here, point here. I could even mark it for 1/4 inch deep. And then I could take here and I drive that point in with the bevel to the inside. I drive this in and I do several verticals here that make this long area. And then I go over the width of my hinge or whatever. I turn the chisel over. I do the same thing on this side. So I've created 2 verticals, and both of them are the width of what chip I want to take out. Now I take that chisel and I chisel out between the 2 verticals. And that's exactly the chiseling process that your cutting tooth does on your saw chain. The left one and right one work together to actually take the whole chip out. So if we understand that, what we're setting up are cutting surfaces, in other words, correct angles, very sharp surfaces, to be able to take that chip out with very little resistance and holding it in proper angles. So 5 parts, that's what we're looking at. And so this is a little bit of lore here to talk about as far as the design on this. You know, up until the middle 40s, logging went pretty well up around Leona, Minnesota. There was a guy named Joe Cox, and Joe was a logger up there, and the war happened and things kind of slowed down a little bit. Well, he packed his family up and they took out to Clackamas, Oregon, near Portland. And he got a job on a helper handle on a big saw. And one day he was working in the woods and he looked over at a piece of bark and there was a wood borer caterpillar that basically looked like a grub worm, beetle larva that was working on that particular bark. And it had these chompers out front, kind of like a termite. Well, Mr. Cox looked at that and all of a sudden it came to him. He said, you know, that's what we need to do to saw chain. Saw chains at that time just had straight, they called them scratcher teeth, and more or less they were angled a little bit with the front edges beveled, and they had a left and a right one, cut a very narrow curve. Well, part of what Mr. Cox had to do in the woods was to keep it lubricated on the big saw so it didn't bind in the kerf. So he was part of that job, being on the helper handle of the saw. Well, when he saw that bug, it just automatically came to him that if we would bend the tops over, we could regulate the amount of width of the kerf. And so he drew it up about 1946, about 47, applied for a patent, was awarded it. And in the early 50s, he began Oregon Cutting Systems. And it revolutionized chainsawing worldwide. And you know, I always tell that story that, you know, if you come up with something that you want to make sure that you think through it and put some value to it, because it could turn into quite a nice thing, you know, for you. Because you start thinking about it. I always tell people Colonel Sanders didn't start Kentucky Fried Chicken until he was 67. So what I'm telling you is you come up with a good idea like Mr. Cox did, watching a bug and revolutionized chainsawing a little bit. We need to talk, because I still have a couple years that I can make some money, and I'll be glad to share. So I always tell that story because it's amazing how many good ideas that I hear out there that people just let float away. But anyway, that's the 5 parts: the depth gauge, the point, the side, the top, and the chisel. And to be able to make sure that tooth is going to work as Mr. Cox's design did, we have to maintain it. We have to take care of all the damage, making sure the surfaces are great. So we'll spend a little bit of time on that. I want to explain it on the actual saw. One of the first things that you want to do when you start to work on chain, make sure that you put your gloves on. You understand that if you do slip, your chain, whether it's sharp or dull, will probably draw blood. So let's make sure that we prepare ourselves. Also, take a look at something here. Let's say, for instance, that we are cutting along and something we hit. So we've hit our saw chain. And what it's done is it's created a situation here. We have a tip that is dulled. So if we were to take a look at the actual file going into the saw chain, you would see that it looks pretty decent on this particular tooth. That file fits the tooth pretty well. But then on this one where I just hit, you can see that there's damage. The point is back probably a 32nd of an inch, something like that. And so that's going to be a situation that we have to clear up. So if I do this, I want to make sure that I take and think through strokes through. Now I want to go inside to outside. And best thing is I would use a stump vise like this, or I would use a bench vise of some type to hold this saw. But just going down through our process today, I just will hold it here with a gloved hand. But I want to file from the inside to the outside of the tooth. I want to hold the file the proper height in that radius so it doesn't back slope or hook. And then I continue making strokes until all the damage is gone. But you know, one thing that I found out many years ago is, and sometimes watching different people file and talk about it, say, make 3 strokes, 4 strokes on each tooth, go around the chain, and it'll cut like brand new. Not necessarily so, because what I see as damage is probably your biggest opponent here. And so what you have to do is you've got to take all of that point damage back off. And to do that, and in some cases it's going to be rounded back over, a good bit there. And so you've got to kind of reshape the front of the tooth, put the point back on to be able to really get the results. So what I found to work very nicely is take your flat file and hold at the proper top angle and just go down in there and more or less take the damage off of the tooth. And so if we do that, we can be able to take and more or less turn that tooth back into undamaged, and then take our flat file, a round file, and be able to put that surface back on. And I can tell you right now, it takes as many strokes as necessary to be able to get that surface back on there, because you have to take and get all the way back up to that point. If you look at it, you don't want any light reflecting off of the chisel angle at the edge of the chrome there. The cutting surface on the tooth is a very thin layer of chrome. And if you have any rollover or damage there, that chrome has to be reestablished to really do its job. So when we start to look at that, no damage can be there. So that flat file takes that metal that's bent or damaged, abrased off of it. Then we can take our file and put that back on. Now, I've got that surface back to where it should be. It's probably taken about 10 strokes, something like that. And now my depth gauge has to be set. If you went to hardware and you picked up Oregon File Guide or Husqvarna or Stihl, there would be some kind of a kit like this. It would be more or less a guide which strengthens the file. You'll get the proper size for your particular saw model. You've got marks on there that would give you the angle, so you parallel that to your bar as you file through from the inside to the outside. The gauge itself or guide itself keeps it from going too high or too low as you do that. And then basically then you would come back, take gauge it like this, and be able to place it on, and then you take the flat file and you file off whatever sticks up through it. And so that's how the kit works. Now, there's several different types that are out there. Now, these all don't fit this particular size of saw chain, but this is a roller guide that Husqvarna has that basically it holds the file up on the rollers. Then you have a depth gauge plate that takes each tooth independently. And to me, that's probably a little bit more efficient way of doing it. So then I came across this type of a tool. And this is called a chain sharp. Husqvarna sells it has been selling it as a Sharp Force in orange. But this manufacturer, Ferd, P-F-E-R-D, they produce this. And more or less, it sets up a round file and a flat file in the holder. And so what takes place here is when you put this down, you're filing one tooth, and then you're actually indexing off the tooth in front. So as you file from the inside to the outside, and it's neat about using the guides, is that you can take and be able to roll back to the middle of the round file as a flat file. So here I can hold that up and make a few strokes to get the damage off the tooth, continue rolling back down, and the last couple strokes against the tooth in front. And now, because it has this flat file in there and they're indexing off the tops of the teeth that kind of go downhill, it actually takes the depth gauge in proportion to the height. And so that's works basically like this one. The other type of a gauge, it kind of takes an average, so you need to try to keep all of those teeth the same length. But it's not necessary with this type of a tool as much. Now, you do want to try to keep all of the teeth the same length because that's what you bought. And the longer you can leave the tooth, the longer it's going to last for you. But if you did get out, and you're working and you hit something, you could actually take the damage off of the damaged 3 or 4 teeth, take a tool like this and be able to put it right back into action very, very quickly. They make these in also for the larger chains also. And Stihl actually has one, it's called a 2-in-1 tool that basically you can just flip over to be able to do the same task. And so it works very nicely also. This is also produced by Ferd for them. But it's something that when you start to look, like I tell people, I really don't care if you stand on your head and do it with your toes. The important thing is that you understand the 5 parts of the tooth, and whatever you're filing with, you can put it back into Mr. Cox's condition, without altering the design. A lot of people talk about grinder systems, and grinders are very effective. Every tooth that comes out of the factory is actually ground, but a lot of people, they don't prefer them to sharpen. And a lot of the reason is they go to pick up their saw chain they've had at shop, and it comes back out and the tooth's half gone, it's all black and blue. They even try to sharpen it, and that's not the grinder, that's the grindee. And so when you start thinking through that a little bit, it actually goes back to the operator. If the operator continues pushing on the chain and more or less takes and puts a rollover on the edge or a damage to it a little bit, then the grinder has to take it all off. And oftentimes you'd have to reset for every tooth, if you were trying to do everything evenly. But so they find the worst tooth, they start to grind on it, then they grind the rest. And yes, if you've got a lot of damage that way, it does tend to overheat the tooth if you apply too much pressure too fast. So you want to make sure that you remove it. And that's where I really started to use that flat file technique, is to take that damage off to use with grinders so it didn't overheat the tooth quite as badly. So that's something to consider. There's also, and going back to what we talked about with the file size, I just happen to think I have a chisel bit file here. This is for square ground chain. And this particular file is a 6-sided file that more or less puts a channel up to the point of the tooth. You see this a lot on the West Coast with professional operators. You don't see it too much anyplace else in the States. But this was one of the first designs, actually, of full chisel saw chain. And so this is very, very quick. It works kind of like the difference between a gouge and a V-tool from a sharpening standpoint. But it's a very, very unique process to go through on that. But that's the 5 parts and a little bit about how it all works. So we will take and look at the next section here. And one thing you want to think about too is that you need to go the right side cutters and left side cutters separately. So you either need to turn the saw over or turn it around. You always file from the inside of the tooth to the outside, and that gives you the chrome kind of coming off on the outside edge, and as soon as you put it into the wood, it'll actually clean itself up. So very important to think through.